And today's talk comes out of a suggestion by Ryan Harden, who really beat up William to give this talk. So we do want to thank William for taking the time to do this. And he's going to be talking a little bit about his experience with Batfish at Texas A&M University. And he's going to talk a little bit about sort of the current state. And I think this is leading into a larger project that he may be talking about at TechX or Global Summit in the not too distant future. So I'll turn it over to you, William.
Great, thank you. So yeah, there is probably a talk happening at TechX in December, and actually one of the folks from Batfish, which really is operated by a group called IntentionNet, they're actually going to come and speak as well. Currently, our time slot will only allow one of us to speak at this point, so you may not hear from me a second time because Dan gives a pretty compelling talk overall. And I also want to make sure that we kind of spread the blame around it a little bit here. James is also somewhat to blame for me doing this. Anyway, so I'm William Deigaard, and one thing I just kind of want to say, the goal here that I had with this talk was to kind of just show you what you can do and try to provide a recipe that is a little bit tailored to kind of our community and some of the tools that we tend to have, so that you can just honestly could cut and paste things from the presentation and have things up and running and be looking at it. The documentation is pretty good for Batfish overall, and some things you can do with it, but it's a little bit hard to get started. And I kind of bumbled around a little bit, so I tried to make this as kind of crisp as I possibly could overall. So a little bit about me, and here's kind of what we're going to talk about, right? Who am I? Texas A&M. Kind of, we have some unique challenges here. Then most of it's going to be about Batfish and kind of getting it set up, and then looking at some of the questions you can ask it and the answers you can get. And I'll show you some of my pitfalls and successes as I went through it. So I was at Rice for 26 years, retired recently to go work on bigger, harder problems, and I found bigger, harder problems here. And then, just so you can understand me a little bit, I'm sort of uptight. I don't like broken things. That's actually how I got my first job. I think it was actually hired on the spot. It's probably the one and only time in life that you can say that and actually have it turn out well. Most people be like, yuck, don't want that. I'm not too badly uptight though. But I really like infrastructure as code. I'm a little bit lazy. I don't want to do things over and over again. I want to automate things. And then I also, like I said earlier, I want to fix things in general. And so to me, the thing that was compelling about Batfish is that it has a lot of these components kind of built into it. You can make things repeatable, automatable, and it also can help you fix things as you go. So A&M, I don't know if everybody knows much about A&M. It is the oldest institution in Texas, 1876. It is really, really big. So our current enrollment as of fall 2018 was 64,000 students in College Station. So that's here on this campus. Undergraduates is 54,000 plus, and then we've got these Association of Former Students, which has seemingly an infinite number of people. If you go by bumper stickers on cars in Texas, you will get the impression that they're everywhere. Pretty committed community of people. They're really cohesive and stick together. It's a 5,200-acre campus. Everybody used to think it was the biggest one, but Berry College has the honor of that, and I think they have something like 27,000 acres because they have like mountains on campus. But we have an airport actually on campus, and I think only the military academies can actually claim that as well. So you can fly in and out. It's kind of nice. A lot of research activities. It's not necessarily something people think, oh wow, what a huge research institution, but it's $922 million annually expended from here, and a lot of it has to do with some health sciences that have been incorporated recently. But there's a tremendous amount of applied research, particularly around agricultural and engineering and things like that. So A&M can help you understand what's wrong with your food supply, for example. And we're also growing like crazy. So that 64,000 number, if you include everybody in this that is enrolled in College Station, but is even not physically here, it's actually 68,000. And that 8,000 jump was actually in 1 year. So 60,000 1 year, 68,000 the next year. The place goes like crazy because we don't have any space limits. And then the campus network, which is where this all comes back around, has 4,300 like networking devices on it. And it's a lot. You'll see why that matters in a minute. Here's our map of the campus. You can see a nice airport over here, and you can see my office is right here in this microscopical location that you probably can't see. There's a golf course. It's a very, very big place. Okay, so a little bit about the network. You know, A&M's had a network sort of as long as any institution's had a network, and it has evolved quite a bit over time. You know, all these things started before web browsers and iPhones and things like that. But this is kind of how I describe it to people. It's functional, right? We're not having roving blackouts or strange outages or anything like that. But it was developed with more emphasis on short-term optimizations, like here's some money to do this, to add this building, or to add a science DMZ, or things like that. There's always a driving factor towards low-cost, easier deployment, like let's hook this up here instead of here. There's not as much redundancy as there should be. It's a highly distributed campus. All kinds of people make decisions that are suboptimal for the institution overall, and it's a pretty tough place to build networks. And so, once again, here's where Batfish starts to become pretty attractive, because it can help you understand things. The next thing is everything is pretty much managed by hand. We have automated tools for gathering, monitoring data, and things like that, but for the most part, there's engineers logging into each of the devices to make various changes. And you know, as you can imagine, 4,300 devices, that's awfully hard to do. And then it's even more difficult to evaluate something before you make the change. So if you're like, well, if we add this here and trunk that there, what's going to happen? Who knows? So there's a lot of care that has to go into those things. And then as a result, when you do, you know, modern day change management, all you can really say is, we're going to make a change, we're going to add some stuff. Oh, what's the impact going to be? Probably not too bad, but you know, something could happen. And that's kind of frustrating for people. And so people write very generic things like, we'll be working on the network on Thursday night. Makes the whole job pretty difficult. And then the validation of things is really not feasible. So a couple of quick maps. This is what it looked like in 1989. I put this in here because I actually think this is a relatively readable map and is understandable. But it was 1989. The most recent map that I found since I've arrived is this one. This is basically parts of the backbone. Not very helpful for anything, really. This is part of my motivation. And then here's what a typical building looks like. We've got these in pretty good shape, but man, there's a lot of configurations, VLANs, and we love subnetting. Variable length subnet masks are like king here. So we got lots of /29s and 28s and 25s and /30s and things like that. It's a very subnetted campus overall. So we need things to help us. We've got to automate. We are working on a new network architecture that will be completely cohesive and has, you know, whether the sort of traditional things that you would expect in a campus network these days. We'll probably end up with an actual core. We'll most likely be doing a VXLAN overlay so we can segment things much more easily, move things around, a lot more predictable. But until then, we've got to work with what we have. One thing is, you know, different people have opinions about this. It's mostly Cisco and Juniper equipment, which is actually kind of attractive because it means there is wide support for the products we have with the tools that are available. In particular, Batfish has some pretty good abilities to parse these things. It's not just networking alone. I'm actually responsible for the systems team that does a lot of software development stuff as well. And so we're very committed to help with that. We're not going to make all these network architects learn how to do computer science programming and things like that. If you can get this in your organization, I highly recommend it. The guy that does risk management policy and life safety for Division IT actually is a DevOps guy. Makes many things start to accelerate quite fast because he sees a lot of weird things that people do and looks for repeatable ways to automate them. And then the Batfish system actually works, right? That was, to me, honestly the biggest surprise. And I'll go into a little bit more about why here in a few minutes. So when I started looking at this, it was sort of a go big or go home approach. I didn't really want to take like a little sample fake network. I didn't want to take you know, a little segment of our network and just work with that. Although that was what I started to do, but I accidentally downloaded all the configuration files and I didn't really look at it. I just, you know, unpacked them and was busy doing other things, kind of working on this. So I actually started with like every single network config that we had in our gathering library, which is around 4,300 devices, as I mentioned earlier. And I just, in some sense, inadvertently threw that at Batfish. So I'll talk more about that in a minute. But basically, I wanted to assemble an environment that allowed you to use both Jupyter notebooks as well as just raw Python scripts. Obviously, I think most of y'all know probably what a Jupyter notebook is. I'll show you a little bit about that. I never really had a good use for them until I started working with this, and it starts to be very powerful because it allows you to kind of experiment and look at things and share things with people in nice ways. But fundamentally, it's Python code that you're actually running. But I wanted to put all that together so that I could do these things on a more systematic basis and wouldn't confuse myself. And these are basically the starting points. Batfish.org, right? It's supported by IntentionNet. There's a fair amount of information there. This Nanog talk that Dan Halpern gave was honestly where it all started for me. I just was I was trolling for Nanog talks, and I stumbled across this and watched it, and it's fairly compelling in terms of what it shows you can do, and it's only been continuing to get better over time. And then obviously Docker, and then Python environments. I'm not a Python programmer by a long history, but finding Python environments was a very handy thing because it allows you to install modules and not blow up your operating system and things like that. So it's a little bit I'll show you on that. So the rest of this is really, kind of what's the recipe and how did I go about building this? So I'm just kind of curious, anybody have any questions so far that they want to ask? Okay, and thank you, James. Yes, it is Beamer. Because if you're going to talk about infrastructure as code, you've got to do your presentation in LaTeX. Okay, so the basic architecture of my setup was I've got a Mac laptop, and I've tried running Batfish on it. Works okay, but eventually you're like, where is my hard drive full? You'll dig around for a while and you'll forget about dot file directories, and then you'll find one eventually, and it has many gigabytes of data in it, and that's why your laptop is having trouble. So for this approach, it's like, just get a virtual machine or a physical server somewhere, and then just set it up in this particular fashion. There is a small typo in here. That second port number should not have an extra 8 on it. But the idea is you've got a Linux host, you log into it, you port forward port 8888 to it, and then you log in and basically this is CentOS 7, so you run a bunch of installations. Obviously make sure it's upgraded, stick Python 3 on there, throw on some Java, some GraphViz and HTOP if you want to see what's happening, and then install some development tools, right? That's set right there, CentOS 7 out of the box, that's kind of the minimum set of things to where you won't run into things missing when you're trying to do them, either through Jupyter notebooks or through the actual just running Python code right there on your machine. And then you install Docker just to make it easier for folks. Here's essentially the recipe. You can pretty much cut and paste this. Obviously, you might want to change that user mod line there on 10 to be your net ID and not mine. But then you can run hello world, and you should get a nice little message that comes back and says, here's how Docker works and things like that. But this is kind of the minimum cut and paste version of this. Works pretty well. I actually ran it myself to do it to make sure it's all going. And then this is where it gets a little bit tricky, right? You set up a working directory environment, right? So you can pick somewhere. I decided to make one called ESNet Talk, and ultimately you make a notebooks directory. Oops. You make a data directory, and then you go in there, set up a Python environment with that Python 3 -m vend, right? V environment, activate it, and then you can install pip. And you can upgrade it to include the Batfish code in there. So that it only sticks that Batfish modules and capabilities inside that Python environment. And it's all self-contained in that ESNet Talk directory. If you want kind of a glimpse as to what that looks like, let me give you a little peek here. Yes, so if I go into ESNet Talk, I've got a whole directory structure here. The bin include the lib and the lib64. and the Python virtual environment, those are all created by that Python 3 environment command. And then the data directory and the notebooks directory are coming up later, right? Okay. So for some people, the next step is really hard. I got lucky. We have NetMRI here, which is an InfoBlocks product, and it goes out every night and hoovers up all the running configs and all the saved configs. And so I accidentally exported all of them. Had a nice tar file, and basically I unpacked it. It was just current configs. And so this is just, literally cut and paste, go into the data folder, make a configs directory, go inside of there, unpack it. And then you can see kind of here's what it looks like. And I've cheated a little bit and I've hidden a couple of things just to make it fit on the slide. But basically, these are the running configs. You don't even have to change the suffix on them. They can be .text or .cfg. They basically just need to be in that folder. Okay, so if you look at it in our environment, it looks something like this: cd data, configs, and you have all of them. I think right now we're at 4361 config files. And they're just raw, unchanged, no modifications whatsoever. You just take them just like that. Oops, I'm sorry, wrong click. That would be a Beamer issue. Okay. So then to make this a little bit easier, I've actually got a little GitHub repository in there where you can basically clone, and you get a little file called tamu.ip and YB. You can kind of clone that and then use that for various things. It has just some stuff already typed in. So you can modify it accordingly. Same things are basically on the Batfish website. So then you start it up, right? So kind of resetting back, go into the ESNet talk, pull down a Docker file. So kind of going back to the picture, get your laptop, you got a virtual machine, and inside that virtual machine, we're going to run Docker. So it's kind of a 3-stage process. And then this Docker command here is designed to basically completely set you up so that you can do a number of things relatively easily. Once it's running, you can do a Docker PS with all these little fancy format commands so that it fits on a slide. You'll see the container ID, the name of it, and then the actual image that's running. So once that happens, you are up and running. And so you now have got all 3 pieces. And then in order to get the Jupyter Notebook working, you've actually got to get a token, which is sort of like a little password. And so you can actually just do a little one-liner, docker exec -it, ESNet, talk Batfish, Jupyter Notebook list. And Jupyter Notebook list is the actual command, and it'll show you this long little URL. And ultimately, you can open that from your web browser because we've already forwarded the ports both from your laptop to the actual virtual machine, and then the virtual machine is forwarding the port to port 888 inside the Docker container. And so that open command actually works on a Mac. It will open up a web browser, and you will be looking at something that's like this. All right, so now you have a Jupyter Notebook running in a web browser, and you've got an actual tamu.ip YNB. You can make a new one, or you can use the existing one. But now you have a full-blown system all completely connected at this point. And so then when you do that, you can start running some commands. I'm going to switch over to a browser and give you a little bit of a taste of what it looks like kind of in real time. And if you haven't used Jupyter Notebooks before, there's these sections in here, and they're called cells. And each one of these cells, you can hit a run command, right? It'll execute. While it's executing, you'll get a little star here in this bracket. When it's finished, you'll actually just get a number, right? So the idea is you load the modules into the Python interpreter, because we're using Python 3 up here, and you load the questions, which is just a function call that's part of these. There's 63 questions. And then this is the sort of the tricky part. You're basically saying, where do I find the actual snapshots? And if you notice, remember we had a data folder. Well, inside of a Jupyter Notebook running inside of a container, what you're really looking at is this kind of configuration. History, and I'm just going to I'm going to connect to the Docker container. So it's kind of a nice way to do it because it's got a name. You can just specify the name. You don't have to do all these weird pasting of names. So now I'm attached to the Docker container. If you do a df, you'll see a data folder there, and that data folder has configs in it, and they're all there, right? So that data, that snapshot path is telling you where those data folders are. Snapshot name is basically an arbitrary thing that you've chosen to call it. It allows you to refer to things later. You can have more than one snapshot kind of loaded at a given point. In this particular case, I just use the config file to date timestamp information from the download. You then set the network to be that snapshot name. And then this command right here takes the path, takes the name, and then has overwrite, which means even if you've already run this before, it will run it again. So I'm not going to click on run here because this takes a good 10 minutes or 15 minutes for 4,300 network devices. But basically, it walks through each of these files and processes them, parses them. You can see the progress it makes as it works through the configs. And it keeps going and keeps going and keeps going. And literally the first time I did this, I was like, well, it's going to crash at some point. Any point now, it's going to blow up. And then it got down to the end, and it said terminated normally. And I have to admit I was shocked because I cannot think of a single product where I've ever sort of pulled it out of the box, followed a recipe to some degree, made a couple of things and mistakes along the way. But ultimately, when I ran it, it actually just worked, right? And the output of that is there's that means it basically processed it. Now you'll see a note here that it initialized but failed to parse some of the files. It can't understand everything in every single file. The intention that folks have an option where you can actually upload your files, and then they will do some analysis to try to understand what's not parsing properly and things like that. And you can read more about it if you run the help command and see how to do that. I've not done that yet because I haven't run into problems that sort of required me to do that. There is a very good Slack channel for Batfish that they refer to on their website. You can ask a lot of questions there, and people jump in and help you actually quite quickly to do various things. If you don't want to go through that whole processing step again, you can do this. Honestly, this is rather tricky to get all figured out just because the names are all slightly similar. But you basically set your network name, and you also set a snapshot name. And so then if you've already run the processing, you don't have to do it again. And you'll notice in this directory, the data directory, there's a configs file which we put there. There's a containers file that it created. And you really don't need to do much with this because it built it for you. If you ever get completely sideways and things aren't working, you can just remove that folder and then sort of rerun that command up top. The other thing that's in here is this concept of hosts. And inside that hosts directory is a little definition of a machine that's sitting on the network. I've not gone to the trouble yet of sort of creating a bunch of hosts all over my network, but you could conceivably take a network inventory and actually construct these hosts by hand. Honestly, you can probably make these things up. It doesn't seem to care what ETH0 is until you start doing things like loading up firewall rules and IP tables and things like that, and using Batfish to do analysis around those things, at which point it does need to know what interface things are bound to. But you can mostly, you just need to provide these last two things and give it a name. You can do various things at that point. Okay, make sense so far? So all that stuff I just did in a Python, in a Jupyter notebook, you can actually just do in Python 3. So you literally can just paste all of this, paste Python 3, you run all of this, and it will do exactly the same thing. And you can use the Python interpreter of your choice. You can also just write all this stuff into a Python script and just run that Python script like you normally would any kind of command. So there's a lot of different ways to access it. This is just a summary of what you're going to see. And it mostly worked, and it's still very usable. So a little bit here, my head just kind of exploded. I was like, I cannot believe this worked. Okay, nothing else is going to work, I guarantee it. So then when I popped back over, oops, sorry. When I popped back over the web browser, the first question I decided to ask was to show me the IP owners. And so to give you a little more of a taste of this, I'm just going to clear this cell, the current output clear, so it's just kind of resetting it. So now I can say run, It'll do a little bit of a block, and then it spits out some results. And the way it's set up with the pandas module that's part of Python, it generates a table automatically. So this answer generates a table, and then the Jupyter Notebook actually looks at that and does things. And so you get the node, what's the default VRF, right? What's the VLAN, the IP, the mask, and if it's active or not, right? And it summarizes it for you by giving you a little dot dot, and then it shows you the rest of it. So in our particular world, we have 9,007 different IP sort of gateways on the network.
Could you make that a little bit larger? It's a little bit hard to see.
Yes, I can do that. Thanks. So better?
Perfect.
Okay, thanks. So you can do other things with this. You can add, obviously the Python code. You can assign this to a variable and things like that. And you can do all that stuff inside of Jupyter Notebooks. You can also do it outside in just a regular script. But overall, pretty impressive. So literally, I had not done anything. I had not edited a file. I had not, reconfigured anything. I just took them sort of out of the box and was able to answer this question. Now, it's not the hardest question in the world in some level, but actually pretty hard to generate all this stuff if you're looking at the configs manually and using your favorite grep, sed, and awk scripts that you can use. So another thing you can do is ask questions like, are things properly configured? So in this particular case, right, we're going to look for our NTP servers, and we're going to basically look for all the ones that have, and it's not border, it's CSCE in their name, because it's one of our building names. And you basically ask the question like, okay, for all the nodes that have the name CSCE, right, and the properties of column name, so NTP servers, then go ahead and give me the node properties and give me an answer, and it'll put it in a nice frame, right? So I'm assigning it to a variable. It'll run that. And if everything in the demo gods are shining on my head, okay. So you get a little bit of job running, and then you get the output, right? It is also truncated like this, right? So it makes it a little bit more, swallowable by a web browser. But you can override that with various pandas commands where you extend the output, or you can just run an actual script. And so now you can look at it and see, here's a particular ASA, doesn't appear to have an NTP server configured, right? This particular device doesn't have one either, right? Some of them have multiples, things like that. Right, but then you can ask maybe a little harder question, because we already have run that. We already have this variable node props defined from the previous. You can actually say, well, you know what? Find me all the ones that have, have nothing, right? And nothing defined. So who doesn't have an NTP server? And you get these. And the line numbers correspond to the array on the original output. But, we got 6 places that don't have an NTP server assigned for various reasons. Okay, so I mentioned earlier we had a network map. We have several network maps. They're not that great. I was determined to get a better map. I tried to talk people into doing various scanning, but it turns out with an audit coming up and security doing credential scans of everything, and about 3 or 4 other tools all scanning the network constantly, our networking team was like, please, Lord, don't scan any more stuff. I did talk them into letting us run SolarWinds one time for a little bit because it was already talking to everything. So we gave it the opportunity to try to map the campus network, and after about 4 days, it blew up, and there was no map produced. This could not handle the volume of devices. We probably couldn't build a big enough VM to actually try to do that. So, back to the drawing board, and so, in the spirit of go big or go home, I tried a couple of different recipes to try to build a map of the campus network. And so, one way is, import the pandas function, set the number of rows to 7,000. That was handy for some other things, but you could do that up here, for example, and you'll see all of them. And then I've kind of run this twice. Actually just show me all the OSPF edges. There's a fair amount of OSPF going on around campus. And then later on, I discovered this approach after talking to some of the folks at PensionNet. Network X is kind of a tool. It's a Python module that allows you to do various things, some of it around network mapping and groupings and things like that. I am certainly no whiz at it. I kind of cut and paste at that point. But then I found this, there's a command, just give me all the layer 3 edges of the network. Like, okay, great, assign that to here, create a graph, and then run this magic command right here, which produces, which is what I was really aiming for, was a dot file. And I don't know if everybody's familiar with dot files or not, but they are, if you like infrastructure as code, they're kind of cool. So here's sort of an example of a dot file. Is that big enough? And they're really simple, right? I'm making a graph called TAMU. Everything below here is a bracket. I rank directory, direction is left to right. And I would like it to be orthogonal splines. And then the rest of it is just relationships. So this network device has a connection to this network device. That's the entire file that keeps going and going and going. Now, this particular script here doesn't generate it quite like that. It generates what is potentially a more sophisticated version of a dot file, because it allows you to have things like line labels and things like that. So at the very top of it, it has all the different nodes. You can add things to that if you want to. And then it has all those device-to-device mappings. So if you run this, it takes a little while, so I'm not going to do it now. It produces a dot file. Now, sometimes that dot file looks like this. And so what the point is, the mapping is getting done, the dot file rendering is not. So this one was pretty cool. I'm most proud of this one here, just because it looks, and some I've been accused of creating a Death Star. You'll notice there is a weak spot here where you can come right in. But it is actually gathering all of these things and grouping them together. And because I grabbed all the network config files, I've actually got multiple networks floating around here, right? There's like a little private management network for some things in the data center that aren't attached to anything else. There's some other things that so you can sort of see everything. It looks like a pretty cool Etch-a-Sketch. This is still a work in progress. I've probably tried every variation there is for dot file rendering that don't blow up. I'm not quite there yet, so a little more of that work to go on. The worst case example is this one using the NITO option. I'm zoomed in about 1 million miles, and now I can read this label here on this particular router, and these are all the connections coming off of it. If you actually back up, it starts to get relatively horrific pretty fast. So, still a work in progress on the mapping. But the point is, I haven't actually touched the network at all to try to gather this information. I've got the relationships. I've actually sort of started to go this route, which is same basic question, just write it out to a CSV file form for me, right? And so you can do things with that. And interestingly enough, that CSV file gets stuck into your notebook page, right? So in here in your Jupyter notebooks, right? That's the Python the Jupyter notebook we're running. Here's the actual output. It gets stuck in the same place. And so you can see kind of what those relationships look like, right? So this host, this VLAN, this IP address is paired up with this interface here. And it's long, it's very long. I think I'm having some troubles with some of these things, but still a work in progress. The main point is I haven't actually broken a sweat when I'm doing these things. You can also figure out the parse status of things. So if you're wondering which files are having trouble, you can see that this one's partially unrecognized, these other ones passed. The other thing you'll see in here is that my little host file definition that I put in actually passed as well. And so my next thing I want to do is I actually want to do some trace pathing through the network. And this code right here basically says, when it works, which it doesn't currently, take this host and try to reach it from this location, and then show me the path. So again, not sending any packets on the network, it will actually simulate a path through the network. And that's kind of a building block for validating what's actually possible through a model. So you could say, here's my network today. I run all my tests on it. It's great. I make a change to that, load that model into Batfish, and then run the same set of tests against it and see if it works. And then you can actually do things like continuous integration where you check in a configuration change, load that into the Batfish, automatically process it. And so when something goes on to another human being for validation and approval, they've got more information at hand that says, hey, our battery of tests have passed. Is Thursday a good day to do this? Is the basic idea. So that's kind of where I'm headed. It depends on, configurations ultimately getting in GitHub, and then the quantum leaps that we'll have to make will be networking architects, not logging into devices, but actually checking out configurations and checking them back in, and seeing we're going to see how that goes. Okay, everybody still kind of with me on this? Yell or chat if you got something that you want to hear more about. This is my slides. This is all in case we blew up and had problems with web browsers and stuff. This is a particularly good webinar here that shows about how to do this sort of pre-commit concept I was just talking about. I'm really hoping some other folks are going to be so excited they want to do this and we can start working together. I have a slight fantasy that I'll be able to model the TAMU network. I'll be able to model portions of sort of the regional network, or it might be a black box. But work with Internet 2 to anonymize some of those configs to model it, and then have another institution somewhere else model their network, perhaps anonymized, and then look at end-to-end path traces as well. The idea is sort of load entire relationships between multiple networks into a single Batfish model. Because if we can handle 4,000 devices, it can handle more as we go. And I think that's it. Any questions on that?
All right. Well, thank you so much, William. Looks like we got one that just came in from Mark. Batfish is cool, but it seems like at least some of the magic is in collecting the configs. Can you talk a bit about how you do that?
Yeah, so we use NetMRI, which is actually kind of I think most people probably are not going to have NetMRI, so it's probably not worth saying too much about that. The other one that is I've used in the past is Rancid. Network config. There it was. It has some abilities to go and actually grab things. I think this is it right here. Yeah, has that very utilitarian look. Yeah, and so we can pull things down and actually put them straight into a Git repository. I would say if you don't have anything today, I would start with this one. Surprisingly, SolarWinds does a pretty good job at it as well. So if you have SolarWinds watching things, it's actually a pretty good way to go. But I would say start here. This is the one we used at Rice to grab them, because our goal was to get them into GitHub. Honestly, before Batfish, we had a lot of fun trying to basically use Unix commands on network configs, which was actually quite fun, because you could say, let's grab all the configs at once, and when a Unix guy shows a networking person what you can do with that, heads sort of start to explode, because they're like, oh my God, you mean I can just check every single uplink interface to make sure they're properly configured? Yeah, sure you can. So, and then actually some other pretty good suggestions in there. I have not used Oxidizer, and yes, you can use Ansible for sure. And if we're going by voting, it looks like Oxidized has actually got more votes at this point.
All right. If anybody else has other questions, feel free to type them into the chat, or if you're in a quiet spot and you don't mind unmuting, you can ask William directly. So I had I guess a functional question here. How much time, and you can measure your time however you see fit here, have you put into sort of where you are right now in learning this, just to sort of give people an idea of what the learning curve is and what they're sort of up against?
Yeah, so if you have the configs already, sort of doing this recipe here, right? which honestly is sort of the hard learned recipe. And it's not like this information is not available on, Batfish's quick start guide and things like that, but there are pieces in here that I just hadn't worked with before, right? I had not really done anything with Jupyter notebooks. So that took me a little while to kind of figure out. And then understanding, they say, use this Docker file, and that's great. But you it's sort of a little bit of a black box. And so you're like, well, I'm just handing my configs this magic thing, and you don't necessarily know what's happening. So I spent some time kind of going down other paths on that and sort of, wanting to build it manually from scratch. And so I put a fair amount of time just in sort of the environment part of all this stuff to get a very repeatable thing that I could use over and over again in different places in sort of an automated fashion. So total time spent probably is about, 15 hours. But with a little bit better recipe, I think you can get that down, and following these steps down to, a couple hours. And you'd be looking at things and being able to see if your stuff is parsable, and you'd be looking at a Jupyter notebook and things like that. The thing that I find maybe the hardest, and this is just probably from my not having a lot of experience with some of these things. I'm not a Python programmer by nature. If you head over to, so you start here at batfish.org, go to the GitHub, right, and eventually you get down here to read the docs. You'll end up with a fairly standard kind of way that a lot of Python things are done, and you'll see things that are really common, right? But they're examples, and they're not always easy to understand, but you get to see things in here. And particularly the available questions, you can start sort of small with like, BGP things. I don't know they've laid this out beautifully. I would actually say start here, which is, did the files parse? Were there any init issues? Are there any parse warnings? Things like that. And then kind of work your way back up to things like network adjacency questions, like this is where the edges are and things like that. And so I tried to put, that kind of approach into the slide deck. So literally you could just cut and paste those things and be able to see some results. And that, relatively positive feedback to me is what actually makes it go a lot faster, because you can sort of see where this is all going.
Okay. And we had a couple more come in. Indira wants to know if you have tried checking ACLs on routers with this.
We don't have a whole lot of them on routers. Most of our stuff is on firewalls, but that is one of the particularly powerful things that you can do with this, because it can parse and understand router ACL. So if you have, ACL spread all over your campus network because you don't maybe have firewalls everywhere, I think this would be particularly powerful when you look at the whole flow path question. So you can make a change to an ACL and you can see what actually happens. I think probably the most interesting thing here really is building a set of test cases that are very repeatable and automatable, so that you can make changes and experiment, and then you can continue to validate those things without having to touch them in a lab that's always a subset of things, or without having to spin things up in some other environment. Another thing I think that's kind of interesting, right, is Juniper has a particularly nice virtual environment that you can use to build various network configurations. So you could do some, sort of real world things in this in an environment, but you can take those configs, pull them out, and then put them into Batfish, and then actually do some simulation, and then actually go in the virtual environment and do the same thing, and see if those failures actually start to matter. The NetMRI question, we have too many network tools that hoover up things and gather things. People don't really actively use NetMRI very much here, but it does have some nice functions in terms of keeping track of like what in devices are plugged into what ports, so it's a little easier to find things with it. And because this doesn't actually look at the live network, it doesn't really seem like it's going to help you understand what's going on like right this instant. It's more of a what can potentially happen if I do something. So it really is a modeling tool as opposed to an operations tool. Yeah, I think that's probably the best way to put that.
All right, if anybody else has any other questions, certainly type them in. I'll thank William again. Send along the PDF of your slides, and I'll make sure that that gets posted.
Yep.
And just as a programming note for everybody, we are on a 2-week pause for the various community meetings. We will pick up again on October 4th, I think. Kevin Thompson is going to give a CC Star program update. Looks like we may be exhausted on questions. So thanks again, William, and hope everybody has a good weekend, and we'll talk to everybody in a couple weeks.
Great. Thanks, Jason.
Thank you.